Hey everyone, welcome to my channel. If you are interested in speaker design and improving sound quality, subscribe and join us. Today, it's time to measure an inductor without an LCR meter. I think this method has never been explained anywhere. So, if you would like to learn it, watch this video till the end and share it with your friends. This method has a good accuracy, and the most important benefit of it is repeatability. It means you get the same result after a few similar measurements. We'll need an unknown inductor, a capacitor with a particular value, a loudspeaker, an amplifier, and a microphone. And we'll need to software REW and filter solutions. The first step is to measure the capacitor value. If you have a quality capacitor which you are sure about its value, you won't need the multimeter. I'm using a 15 microfarad capacitor for now. Now measure the DC impedance of your speaker. For this experiment, the DC resistance of the speaker is enough, because the results won't rely on the speaker impedance. But if you want to design a crossover, the speaker impedance is very important. As you can see, my speaker resistance is about 6 ohms. If you know the DC resistance of your speaker, you won't need a multimeter. Connect the unknown inductor and the capacitor in parallel. Now, one of the two connectors must connect to the plus polarity of the speaker, and another one to the plus polarity of the amp. First, connect the negative polarity of the amp to the negative polarity of the loudspeaker. This is a notch filter which consists of an inductor and a capacitor. It doesn't allow the mid-frequencies pass, and it creates a deep valley in frequency response. I've made a few videos on crossover design, but I'm going to make some videos about passive filters and explain all types of them. Although the method used to measure the inductor in this video does not need to know about filters, and everyone can use it. Let's do a measurement. As you can see, there is a deep valley here. This is the key to measuring the inductor value. Expand the frequency response, and note the frequency at which the valley has been occurred. Open Filter Solution software. I use the 2013 version. I think you can find it on the web with a few searches. As a summary, this is the order of the filter, and set it on 1 for now. This is the frequency at which the valley occurs. The bandwidth of the filter, set it on 1000 for now. Don't change this setting. Enter the DC resistance of your speaker here. That was 6 ohms for me. For the remaining sections, do the settings as shown in the picture. Click on the capacitor to open its related window, then change its value to the capacitor in the said circuit, which was 15 microfarads for me. Make sure this checkbox is checked. Now compare the obtained value with the LCR meter value measured in this video. As you can see, this method has a good accuracy. Now, let's do another measurement with the 3 millihenry inductor. Do all steps as before. If the V-shape occurs at a higher frequency, for example, 3000 Hz, you should choose a capacitor with a lower value. In this case, the V-shape occurred at 758 Hz, and I can use the previous capacitor because the change at the V-shape frequency is not significant. This method is more accurate for inductors between 0.5 and 5 millihenries. The result shows the method has an acceptable accuracy. If you perform it a few times, you'll find out it is also repeatable, and the results will be the same.